I know what you're thinking. With Git so popular, does Microsoft use it internally? Absolutely we do. I know what you're thinking. Doesn't Microsoft's code base stretch so large that it would slow Git down? Absolutely. That's a problem that needs to be solved? No, that's a problem that we have solved. That's what we're talking about on this episode of Dev Radio. Hi, and welcome to the next episode of Microsoft Dev Radio, and you are going to like this one. I've got Saeed Noursalehi. He's a program manager with the Visual Studio Team Systems team, and he has, with his team, created something that is going to blow your mind. We also have Christian Allred. He's a senior software engineer. He's behind the scenes and helped put it together. He's on the Windows File System team. And here we go. Christian, let's start with you, man. Thanks for being on the show today. Before we start talking about the Git Virtual File System here, talk to me first about who you are.
So, like you said, I'm Christian Allred. I am a software engineer on the Windows File Systems team. I've been working at Microsoft for a little over 15 years in file systems the whole time. The first thing I worked on at Microsoft was something that is sadly deprecated now. It's the transactional NTFS extensions to our file system. I've worked on the filter manager. I own the volume snapshot driver. I've had a hand in some of the WinRT file system APIs, just kind of up and down the stack in file systems.
But it's always file system all the way. Tell me a little bit about the Windows file system. Is it pretty good?
Yeah, I think so. So our file system, the main file system that we have, NTFS, has been a part of Windows NT since its inception. We have some other file systems that our team owns too, FAT, exFAT for like mobile applications, and we have also our newest file system, REFS, that right now is primarily in servers, but is making its way through to other elements of Windows. But yeah, the NTFS file system has been with us for a long time. It's seen continuous development over its entire lifetime, and it's just getting better and better.
Now, our REFS eventually someday will eclipse NTFS, and we will stop saying NTFS so fast, and we'll start saying REFS. And people, do you guys not pronounce it REFS?
No, I've never heard anybody pronounce it REFS. I usually hear people pronounce it REFS.
That's probably a better. I'm sure REFS means something terrible in some other language, so it's probably better we stick to just the letters, for sure. All right, Christian, thanks for being here. I'm excited to talk to you about this. It's a cool project all the way around. Saeed, now thank you for being on the show too. We're gonna get into the nuts and bolts here, but before we do, just introduce yourself and who is Saeed? How long you been at Microsoft? The whole shebang.
Sure. I'm more of a journeyman than Christian is. I've been around for about 14 years or so, but I've worked on a few different teams. I worked on Exchange Server for a few years. I worked on an Xbox 360 game for a while. Mm-hmm. I've been here in Visual Studio Team Services for about 3 years, working on our Git product all up, mostly just focused on large teams within Microsoft and specifically focused on their scale problems. That's what we'll be talking about today.
Oh yeah. Let's talk about VSTS for a second, because I love the product. As people are adopting cloud-based, and people don't freak out quite as much as they used to about putting everything in the cloud because they realize what's going on. At the same time, what do you see? TFS proper that's on-prem, and then you have VSTS in the cloud. How's migration going into the cloud?
Both products are still thriving. Okay. And I think, there's more and more companies, I think, recognize that offloading their infrastructure and letting somebody else deal with all that pain is a better use of their time and money. But then, you have plenty of companies who just need the level of control that they get, or they need access to the back-end data, or for whatever reason, they still continue to use the on-prem product. So both are alive and well, I think.
But both are alive as well. What about feature parity? Are they identical, basically?
Basically, I mean, VSTS picks up new features much more rapidly because we release every 3 weeks to the service, whereas we release quarterly to for the on-prem product. But as far as
wait, is that the flow? Just like SQL Server releases first the SQL Azure, and then that becomes the on-prem SQL feature as well. Is that the way you guys have it as well?
Essentially, it's all the same code base, all the same product. Configured slightly differently, and the release cadences are of course very different.
All right, so VSTS. One neat thing about VSTS, and I know this personally, is we use it ourselves. Like, this is our source control. If we could go back 5 years, that really wasn't true, right? It really hadn't been something we had wholesale adopted internally, and then all of a sudden, this is our actual tool. Did that change the culture inside VSTS?
Absolutely. I mean, the whole company is our customer at this point, and we VSTS are our own customer as well, and so we have a very strong culture of we use our own products on the bleeding edge. We have a ring in VSTS that is just for ourselves, so that we're always on the absolute latest. Mm-hmm. We then quickly go out to the rest of the company before we go out to the world, and we're always making sure that we are validating it ourselves before we put it out to anyone else.
All right, so when it comes to large dev teams and significant code bases, Microsoft pretty much sets a lot of the bars out there. In fact, Microsoft is not the normal software development company out there. We're kind of special. To kind of describe how Microsoft is unique.
In some ways, the majority of Microsoft is fairly ordinary. We have thousands of repos in Microsoft, all using normal Git, using normal Git workflows. A lot of them, are just no different than teams out there. But we have a few teams at Microsoft that are extremely unusual. We have the Windows team, for example, that has around close to 4,000 developers, all trying to work in one repo. And
all trying to work in a single repo.
That's right.
Okay.
Yeah. And like out in the real world, outside of Microsoft, a repo with like 100,000 files in it would be considered really large. And we add a couple of zeros onto that. So we're pretty unusual in that way that we have a handful of these repositories that are just gigantic. The Windows team is now fully onto Git, but we have other teams as well. Like Office is in similar scale numbers, and they're thinking about migrating to Git as well, or not thinking about it, but working on it.
So wait, I think I hear kind of a subtext of what you're talking about internally here, that we're all Git.
The vast majority of the company is now on Git, that's for sure.
Okay.
Yeah.
And to be clear, we're talking about the Git protocol, right? And being able to use that way. Let me back up just for a second, because I heard you say so many interesting things just then. All right, so if I were outside and I was writing, Git, and I wanted to test it, I would put my 1,000 files in there, and I would check, and I would check and constantly commit different points, rebase it again. Hey, it looks great. Hey, let's try this on something big. I go to 100,000 files. Do all the same sorts of tests. I'm like, man, this thing is doing great. Then we bring it into Microsoft. What was our experience as we started using the tools that, really the rest of the industry was saying was awesome?
Well, like I say, for many of our teams at Microsoft, the tools work great. What we've done though is we've taken sort of the raw workflows of Git, and we've sort of beef them up for enterprise scenarios. And what we've done with VSTS is we've done things like make sure that you can configure your repo to protect certain branches, for example, right? Like you don't want everyone to be able to push straight to master and break your code. And so we set up requirement to do pull requests, or a requirement to run a build and get a code review before you can merge into master. So we've really enhanced Git to work well for enterprise teams, and make sure that you can keep your quality up and have good release management out of that, and all those sorts of things.
Now, for centralized source control, we call that a gated check-in. I still accidentally call commits check-ins. But
Right.
what do we call it on the Git side?
Well, we really push the pull request workflow, and so
Okay.
yeah, what we do is we encourage teams to require pull requests into master or into their important branches, and within a pull request, you can configure all sorts of controls. You can configure various builds that have to pass, various tests that have to pass, particular people that have to code review, things like that. So really, when we talk about the workflows, we talk about pull requests a lot.
Okay.
Yeah.
All right.
Yep.
So now so great. It works terrific, and you guys have tailored VSTS to have more enterprise-facing features. Let's talk
Right.
about where we ended up. Like what was the edge case that we had to solve?
Well, about 2.5, 3 years ago, we started looking at, well, what would it take to bring Windows into Git? And the real issue with the Windows team is just the sheer scale.
Yeah.
The number of files in the repo, the number of branches that they're going to create, the number of people constantly pushing to the repo. And there was no way we were going to be able to scale to that. And so we had to figure out, what are all the different ways that we're going to, what are the challenges that we're going to hit with the Windows team, and how do we fix them all?
Talk to me a little bit about how you knew that it wouldn't scale. What were some of the early experiences?
So, back then, even the VSTS repo, which is quite a lot smaller than Windows, was sort of pushing the limits of Git.
Oh.
And so we could tell, even with our own repo, which, back then we had about 300 or 400 developers, a tenth of the size of Windows. We had about 100,000 files, and even with those numbers, we were starting to find the limits where operations just take a long time. Like you do a git clone or a git status or a git checkout, and it's not as zippy as you'd like it to be.
Mm-hmm.
And so we know if we take these numbers and multiply them by 10 or 100, it's just not going to be usable.
Yeah.
And in fact, we did some experiments early on. We took the whole Windows code base and we created a repo with all the code in it. And you try to do a git clone, and it would take 12 hours just to clone it. And that assumes that you don't lose your connection while you're doing that, because in reality, a git clone is not resumable. So if you lose your connection, you got to start over.
Yeah.
So really, it would take you 3, 4, 5 days to get a clone. And then the very first thing you're going to do is run a git status just to see what's what, and that
Right.
takes 10 minutes on that repo.
Because what changed in those 3 days? Exactly.
Yeah. And so, and just to tell you that nothing has changed at all in your repo, it would take 10 minutes just to scan those 3.5 million files. So it was just not usable at all. And we had to go figure out, some way to do that. And we tried a lot of different approaches before we landed on our current solution.
Now, talk to me just a little bit about using Git in the first place. It sounds like the team hadn't used Git up until then, and they were using their own. It was internal something. And what was it called back then? Do you remember? Or what our internal Windows source control was?
Previously we were using Source Depot, or the Windows team was using Source Depot. Yep.
And nobody else was. That was ours. We wrote it for ourselves. And so they were. Wait, what's that?
Well, Source Depot started its life as a licensed. We licensed the Perforce source control system, and then we started, modifying it. So we got a source license to Perforce, and then we started modifying it for our very specific requirements.
Right.
And it worked great for us for years and years.
I love knowing the backstory of all these crazy things like that. That's terrific. And so it started then, not as our product. We just, I branched it in a sense and kind of went from there.
Essentially, yeah. Yeah, cool. It was an internal-only fork of this product, so that it could meet the requirements that Windows had. Because Windows was split into several what they call depots, sort of like a repo. So Windows was split into several depots, but we had to have these tools on top of it to kind of bind the repos together when you would do an all-up build of the whole product.
Mm-hmm.
And that's what we used for quite a long time. When I first joined Microsoft over 15 years ago, they had just finished transitioning to Source Depot from the previous source control system. Because kind of for similar reasons, because Windows was getting bigger. The old source control system didn't scale, and it was apparent that it wasn't going to scale as Windows continued to grow.
Wait,
And then,
Christian, walk me through the mentality here. Was there a problem with Source Depot we were trying to solve, or was there something special about Git we were trying to go to?
more the latter than the previous. There were some issues because of the way that we were so Source Depot worked great for the development model that Windows had for a very long time. When we were on long release cycles, 3 years or more, the way that code would flow through the system, Source Depot was great. But when Windows decided to move to a faster release cadence, with the advent of Windows 10, and even before then, when Windows 8 and Windows 8.1 came out shortly thereafter, and then Windows 10,
right?
And then we moved to now the release cadence we have, where we're releasing, at least every year, every 6 months is what we've been doing. It became apparent that the code velocity, as we refer to it, the code couldn't flow through the system fast enough. And so we had to change our development model. And Saeed can speak to this too, because they did a lot of research into why Git. But Git wound up making the most sense to be the thing to move from Source Depot onto.
Okay. Saeed, I can't help but ask, why Git?
Well, Git is a really great tool for creating the sorts of collaborative workflows that we're trying to move towards. We're like Christian alluded to, with Git you have a much easier time achieving that sort of code velocity because it's it's super fast to create a branch, party on that branch, share it with your teammates, and then the whole pull request workflow, getting those changes back into the master branch. It's amazing the efficiencies that unlocks. Already, the Windows team has now been on Git for a few months, and we've had people emailing us saying, there was a specific example. Somebody emailed us and said, there's something I've been wanting to build, and it's been on my personal backlog for 3 years, but I could never do it because it was too painful to work in, to create a branch would be too painful, and then to try to work on it without checking it in was too painful. But within the first week of being in Git, he created a branch, did some prototyping, pushed it up, got some feedback, and got the changes merged in. And so, we really wanted to encourage folks to have those, those more nimble, agile workflows, and it's really paying off, I think.
Yeah, when you could take a gigantic code base and treat it like a teeny tiny code base because that's all you're working on, there is a beauty to it. Okay, let's talk about the problem you hit so we can talk about the solution we're here for.
Right. Well, we've hit on a little bit of it, which is the scale of the Windows code base is just astronomical. We've got 3.5 million files in the working directory at the tip of master. And that's not even counting history or anything. And that's about 300 gigabytes of source files. And so just the sheer cost of scanning through those files and doing something like a git status or a git checkout, it just makes it so it's unusable. Like I said before, it was about 10 minutes to run git status. It was about 30 minutes to do a checkout. And actually, I take that back. It was about 3 hours to do a checkout. To modify one file and then to commit it takes about 30 minutes. So it's you just can't use it. There's no realm in which that would be usable.
Right.
And so we had to go and figure that out. How do we make this practical so that people can actually do their work?
Well, tell me, what's the bottleneck? What's the thing that really is creating this slowdown?
The bottleneck is Git was designed with the assumption that because all of your contents are local on your machine, and because most repos have, maybe a few hundred or a few thousand files at most, they kind of optimized Git so that you don't have to do commands you don't have to go and tell Git up front, I'm going to go edit this file. You just go and work on whatever files you want, and then and then status can just go and scan the whole working directory and find what files you modified. And so they made this assumption that scanning the working directory will be fast enough, and that comparing the contents of each file will be fast enough. And when you have 3.5 million files, that just falls apart.
Got it. Wouldn't be the first time developers and architects made too small of an assumption around scale, for sure.
Right.
All right, and so we had to come in and solve this problem. What happened?
Well, our first approach was, let's just take this code base and split it up into a bunch of smaller repos. And we tried a few different iterations on that idea. And you know, we had a lot of we learned a lot of lessons from doing that.
Okay.
And
yeah.
the biggest thing we learned is you can't really take a code base that like if the code base is a particular size and you have to build it all together and release it all together, you can't take that code base and divide it up into smaller chunks just for arbitrary scale reasons. It doesn't really work out. In the end, you create more complication for your development workflows. And because you have to figure out, like, okay, now I have these 10 repos that make up the one code base, and what commit from these 10 repos do I have to bring together, and how do I make sure they're all in sync, and what if one person modifies this repo and another person modifies that? It just creates a lot of problems.
And over time, they'll inevitably get bigger as well.
Exactly. Well, and that was one of the big problems, is that we looked at dividing up the Windows code base into a handful of what we were thinking of as modules, but it had to be, each module had to be something that could at least compile on its own. And one of the modules, the smallest we could get it, would still have been larger than anything you could use with Git as it was. So splitting it up just didn't really work out.
Okay.
And
so we throw away Plan A or Plan B, I guess.
That's right. We had a few different iterations of that. We tried submodules, and we tried using some custom tools to just stitch together multiple repos, and yeah, we ended up ditching those plans.
Okay.
In the end, we kind of realized the only way to make this work would be we could have gone and tried to rewrite a lot of the guts of Git, but we really didn't want to do that. We didn't want to have yet another internal only tool that sort of looks like Git but isn't really. Really what we wanted to do was to make sure we're using the same tools as everyone else. And when you go on some public forum and you read about this Git command or that Git tool, like it should be the same inside Microsoft as it is outside.
Yeah.
So we rejected that idea as well. And so that's kind of what led us down to this idea of, what if we, instead of changing Git, what if we virtualize the file system underneath Git so that Git can still make the same assumptions that it does and wants to go scan the files and whatever, but we essentially hide much of the file system from Git so that it doesn't have to go and do all that unnecessary I/O.
Oh,
that was kind of the root of the idea, was what if we just make the repo look smaller?
What if we just... Yeah, so all the same mechanics are there. We just trick it to think it's a tiny little repo.
That's right.
Wow. Okay. What does that look like?
Well, what it looks like in the end is it looks like all the files are there. And the cool thing about that is you don't have to go and fix your build tools or your IDE or any of the tools that you use to work with your repo. They all see the files. The files look like they're there on disk. And the first time you go and open a file, it just materializes under the covers. And all of this actually has a secondary benefit too, which is, the main problem that we're solving with Git is that it has to go and scan 3.5 million files. But there's also the second problem, which is when you have that many files, you also have a lot of bytes. And so, copying 300 gigabytes of contents over the network just so you can check out your first commit, it takes a long time. And so we actually get this other benefit with virtualization, that you don't copy any of those contents unless you actually need them.
Nice.
Yep.
Kind of on demand. Now, Christian, listen, Git has some problems when there's too many files, and I have to scan all these things. I was thinking maybe a virtualized file system. Somebody actually came to you and said something like this. How did you respond?
Well, we said, you know what, we do have some virtualization products going already. Why don't we take one of those and see if we can make it solve this problem? So The part of GVFS that works with the file system directly is called a file system mini filter, and we'll talk about that in more detail later.
Okay.
But that part, we already had a mini filter that was doing file virtualization for containers, like Docker containers. And so what our filter actually is we took our existing Docker container filter and we said, okay, what can we do to this? We'll use this as a base to build on to create this virtualization product. And I want to say, a minute ago you said, what does that look like, virtual file system? And I thought, well, if you do it right, it looks like the file system.
It's transparent.
That's sort of the point of virtualization.
That's right.
Yeah.
And so then work started to happen, and I guess, Saeed, you realized this is going to be a product or a feature of VSTS, or this is going to be a product that we will provide externally. What was the future? What was the plan at the beginning for?
Well, from the very beginning, our plan was that this will be an open source product.
Okay.
Yeah, GVFS. So GVFS is made of two parts. There's the filter that Christian alluded to, and that is down deep in the guts of Windows, and there's a driver there. But then there's the things that there's the GVFS product, which is just an application that knows how to talk to this driver, and the GVFS code is all open source. It's already up there on GitHub, and it requires a GVFS protocol to talk to the server, and that protocol is also public, and we're working with other companies already who are implementing that same protocol. So the plan has always been to make this available to anybody who would, any service who wants to support it, and any customers who want to use it. Yeah.
Have you started getting any pull requests externally on your open source repo yet?
Nothing too significant yet. There's a huge barrier to entry because working on file systems is not easy. But we're actually working with an external team who is they're focused on building their server side pieces of it, and then they're looking at coming and contributing into the client side as well. But like I say, it's a hard piece of code to really to dig into. Yeah. And
it's probably more than one file.
Yeah.
Let's just paint the picture here. GVFS is the Git Virtual File System. That's right. Is to solve the problem of what if you have so many files that the infrastructure of Git by itself just cannot, it just bogs down. What if we could virtualize that whole thing so it's faster? Then we could start applying Git into our teams that are gigantic and to actually use all the same tooling. Let's make it open source. Let's make it public. Let's make it so that anybody externally can use it so that all the documentation is available for all of us and for them. They get to see all of our innovations and we get to benefit from any of theirs as well. That's the high-level umbrella of GVFS.
I think you nailed it, yeah.
Yes, the next thing is I want to see it. I think a demo and kind of walking through some of the implications of what this means to my Git workflow is the right thing to do, but not the right thing to do perhaps on this episode. So I'm going to ask Saeed, you and Christian, would you be willing to come back and show us GVFS? Just kind of, we'll share some screens and you can show us what it looks like?
Absolutely.
Yeah. All right, perfect. All right, if you're a developer out there and you use Git, you're not alone. Seems like everybody uses Git, and it turns out that as your application grows and as your team grows, you have some different types of things that you might need to solve. Depending on what kind of company you are and what kind of code base you have, you may be backed into a corner. Well, isn't it cool to know that so were we, and we needed to solve this problem, and we did, and it's here to share with you. Join us next time on an episode that you will absolutely enjoy. We will nerd out with these guys. This is Dev Radio. Saeed, thanks for being on this show. Christian, thanks for being on this show too. I look forward to seeing you again.